Bismillahirrahmanirrahim. The last chapter in the textbook Ferozan, inshallah, we will be looking at standard client-server protocols. So, while the book covers more, obviously, we will be looking at three: the World Wide Web and HTTP, FTP, and email. So we covered in class the history of the World Wide Web. I will cut short in this video and go straight to the explanation of how HTTP works. HTTP really is the main protocol that we use to access web pages, to access the internet. And we need to look at how this protocol actually works. It's an application layer protocol, okay? All the protocols we are looking in this chapter are application layer protocols. And HTTP, which stands for Hypertext Transfer Protocol, okay? So HTTP, just to write there what it means. Hypertext Transfer Protocol. Now, in HTTP, documents are arranged in the form of web pages. So every page will have a unique web address. So based on that address, using that address, you can find that web page on the internet. If you type that web page address in your browser, it should direct you to that page only. Initially, when the internet was made public, we had pages that were mainly text documents, or you would have text documents referring to other text documents using hyperlinks. But as we have progressed in the past decade, we no longer use hypertext only, but we make use of hypermedia, right? So what we make use of is hypermedia. So the web address does not refer only to text, but it could be audio, video, images, and many other types of information. So, but the key point here is that each one of these entities will have its own web address. And these web addresses, these web media are independent, okay? They exist independently. So just because in a website, in a web page, we have different links, it doesn't mean that they are dependent on this page, right? Each one of these links will be direct you to an independent web page. So this is what we mean by hypermedia. So in example 26.1, it says Assume we need to retrieve a scientific document that contains one reference to another text file and one reference to a large image. So we have one main file, file A, and we have this file referring to two other contents. One is an image and one is another text file. And it says here that the main text file, okay, the main scientific document, which is file A, and the image, which is file B, they are both stored on the same site. And the other website, the other text file, is stored in another site, file C. So we are dealing with three different files, and we need to see how can we access those documents. So as you can see here, the main file and the image are on site 1, stored on site 1, and the referenced file is on site 2. So the client will send the request 1, which will grant us access to file A, which is the main file. And then when the client clicks on the link to the image, he or she will be directed to the web page for the image. And when we direct it to the third document, which is the referenced file, this is stored on another site. So our request is actually now directed to the other site, and we receive a response from that site. So this is how the basic working of HTTP is. Now, we have in here the example of the URL, okay? How the URL is used to identify or define, right, the web page on the server. What does the URL consist of? It consists of the protocol. This is how it's written, okay? So you have the protocol : // and then you have the host domain or IP address, and you have the port that you will be using, and then followed by the path on the machine. So in here, the protocol is HTTP. The host part is www.mcgrawhill.com, okay, MHHE.com. That would be the host part. So in here we are referring using the domain name. We could also refer it directly using the IP address. But because IP addresses are difficult to remember, we make use of domain names. Port in this case would be 80 because it is HTTP. But if a different port has been used, it must be specified in this part. If it's not specified, then the assumption is that it is the default. And then we have finally the path, which will tell you where exactly that file is located on the computer or the server that is storing the web page. So in this case, on the computer with the domain name mhhe.com, we have a directory called compsci, and within that directory we have a subdirectory Forozan. So then Forozan in turn would have other entries in here, different web pages. So this directory structure is really like the way we have it arranged in our computers. It's just straightforward. So this was the example of how we define the URL. So the Hypertext Transfer Protocol, or HTTP, is used to define how the client-server programs can be written, right? It will tell us how can we write programs to retrieve web pages from the web. So how can we get the web pages, and how can we also put information on these pages? So the HTTP client will send a request, and the HTTP server will return a response. Always get that. The person, the device requesting the information will be the client, and the device serving the request will be the server. So you could just have two normal computers that, and one of them's having a web server running. So in this case, this would be the client, this would be the server. So an HTTP makes use of the services of TCP. So the reliability of TCP is exploited by HTTP. And as we know, TCP offers a connection-oriented and reliable service. Now we will look at the different types of HTTP connections. The first one we have is called the non-persistent connection. Okay, non-persistent connection. Now, as we know, HTTP makes use of TCP underneath. So, which means when a request is to be sent between a client and a server, we would have to first establish the connection. You know, TCP has got the three phases: connection establishment, data transfer, and connection termination. So in non-persistent connection, for every entity that we access, we make a separate TCP connection. Okay, this is very important. So for example, in this case, we have a client needs to access a file that contains one link to an image, right? So you're accessing a file, and then within that file you have a link for the image. And we're saying that they are both located on the same server. But because it is non-persistent, what happens is every entity that we access, the file and the image, they will have a separate TCP connection. So we would first establish the handshake and then for the file, and then we do the data transfer, and then we do connection termination. Again, we establish another connection for the image, do the connection establishment, do the transfer of information, and then do the termination. So in a non-persistent, you would have something like this. So the client wants to access these two files. So it will first establish the connection establishment phase. Okay, after the third handshake, it will send the request. The server will respond with the file, and then the connection is terminated. Now to access the image, once again, you set up a new TCP connection. The image is transferred to the client from the server, and then the connection is terminated. So this is important to understand. In non-persistent, for every image or file or web page that we access, we will create a separate TCP connection. Even though these entities are on the same machine, it would still make a separate TCP connection. So this was non-persistent connection. Now we will look at a persistent connection. In a persistent connection, we have only one connection that is established. And once we establish this connection, we then start sending information, multiple types of information. Okay? And then once everything is completed, we then can disconnect or terminate the connection. So in a persistent connection, now we are using the same example of retrieving the image and file. So you have the first handshake, establish the connection, and then we send the request and receive a response from the server. We send another request, this time for the image. We receive another response from the server. After we have completed the transfer of all these files, we then terminate the TCP connection. So this connection, in a persistent connection, the server keeps the TCP connection open. Until when? Until either the client terminates it or there is a timeout. So you wait for some amount of time. If no request comes from the client, then you terminate the TCP connection. So the advantage of a persistent connection over a non-persistent connection is that in a non-persistent connection, we would have too many messages going back and forth, and this would increase the overhead. Whereas in a persistent connection, we have brought down the number of messages. So these are the two different types of connections we have: persistent and non-persistent. Next, we look at the format of our request and response messages. So in here, now, as you know, we are communicating using a client and a server style of communication. So the request message is sent by the client and the response message is sent by the server. Now in here we have the request line that will tell what we want. It begins with the method that will tell what specifically is it that we want to do. In this case, we could have get, which means we are requesting a document from the server. Head, we are requesting information about a document, but not the document itself. So we could request things like, when was this document last modified? What is the type of document? What does it contain? Images, videos, audios. What is the format of the information? Is it JPEG? Is it PDF? Okay. So we could request information about the document, not the document itself. So this is another way of retrieving, another method of retrieving information. And then we have put, where we are sending a document from the client to the server. So in this case, if we were to upload something, we would make use of put. And then we have post. In post, we are simply updating some information. We are not putting in a large amount of, you could say, information. We are simply updating it. And in these cases, we make use of post. So an example would be if on Facebook you are uploading a comment, then you could do post. On a discussion board, or on a discussion forum. If you are posting your comment, then you would make use of post. So you are sending information to the server. Trace is used for debugging purposes. Delete removes the web page. Connect is used by proxy servers and it has been reserved for special purposes. And then we have options. When we give this command, we are inquiring about the available options to us, and we will look at it. So this was about the method. And then we have a space, and then we put the URL of the web page. So where is that information going to come from? Now this would be the URL that we discussed earlier. So it would be your protocol, port number, host number, things like that. So that information would sit here. And then we have a space, and then we have version. What version of the protocol are we using? Carriage return line feed, which means new line. And then we have the header. Now, to look at the response side of things, we have the version of the protocol, space, status code. Now, this status code will tell us more information about the task. Was it successful? Was it unsuccessful? If it was unsuccessful, where was the problem from? Was it from the client? Was it from the server? All types of information will be suggested by different status codes. So an example of that right, so it doesn't seem like we have the example page here. Just to show you an example in this case, so we have, for example, the response coming back with 200, and this 200 means that everything was okay. And that's what the phrase part means, okay? The phrase part will explain what the code means. So this is the status line for the response message, which is coming from the server. And then we have header lines. In this case, we're giving more information about what we need. And then we have the blank line. And then we have finally the body, which will contain the information that is to be sent to the server. And in this case, this will contain the response, which will be the body, for example, the file that you requested, or the image, the video, things like that. So now let's see how we will look at the header details further. So we looked at the methods. Now let's look at the request header names. Okay, so what's happening so what can we put in here? Request header names, right? Not here. So we are looking at the request header names. We have the user agent, so you could use this to specify more information about the client program. Then we have accept, which will specify what media format the client can accept. So I could say, I can accept .doc documents, or .docx, or RTF, or TXT, right? So if I'm saying accept, it would mean I'm accepting these formats. of text, which means PDF might not be acceptable. So the header really is being used to specify more information about what the client is requesting. And then we have accept character set. This shows what character set we can accept. So can we accept the character set with some character like this? This would decide. Encoding, ASCII, Unicode, different types of encoding. What type of encoding can we accept? What type of languages can we accept? Authorization, what permissions does the client have? Does the client have permissions to read only, or is it read, write, modify? Host, it shows the host and port number of the client. The date, what date has this request been sent? Upgrade, it specifies when the server is to respond, what would be the preferred protocol? Cookie, when we have a cookie and we could use this command to return the cookie to the server. If modified since, this would mean we will look at this command later on, as we have an example coming up on that. So all this information can be specified in the header lines, and additional messages will be placed in the body. Now to look at the header details for the response side, these are the request header names, these are the response header names. So the server will respond with the date, show the current date. So which would mean your response was sent on this date at this time. Again, upgrade to specify the preferred communication protocol. Server, it'll give information about the server, what type of a server it is, okay, different types of information. Set cookie, the server will send a cookie and ask the client to save it. Content encoding, it will specify what encoding the server is using, what language it's using, the length of the document being sent, the type of the content. So is it, what type is it? Is it text? Is it audio, video? Location. Now, if that information is no longer on that website, but the server knows where it is, this location will be used to direct the client request to that different website. And then we have accept ranges, and we have the last modified. We will look at this in the other slide. Now we are looking at an example of how we retrieve a document using the GET method. In this case, the client first sends a request to the server saying get /user/bin/image1. So the client is requesting the URL, which is an image using protocol HTTP version 1.1. And the client specifies that I can accept a GIF or a JPEG type of image. The server responds back with the version of the protocol, the status code saying the request was serviced without any problems. It will give the date of when the request was serviced and the time when the request was serviced, what type of a server it is. It's a challenger server. Content encoding, MIME version 1.0. So we are sending an image which is now being encoded using the MIME extension. And the length of the file that is being sent is 2048 bytes, and this would contain the actual image, the body of the document. So this is an example of how an HTTP request and response works. Now we are looking at the modification, if modified. So we are sending the request line, the client sends the request line saying, get information from the following URL using HTTP version 1.1. But in the header line, it specifies that get it only if that information has been modified since Thursday, September 4th. Which means if the information was modified after this given date, the server should send the information. If not, then the client does not need that information. Why is that? Just to quickly cover the concept of proxy servers and caches. We have, anytime the client makes a request to the server and the information comes back, the information is stored in one of two places. It is either stored in the client in its cache, or it is stored on a proxy server. So the proxy server, if the client has been configured to access the internet using the proxy server, it means it will send the request to the proxy, and then the proxy will send the request to the server. And then when the information comes back, it gets stored in the proxy, and then the proxy will service the client. Okay? So in this scenario, the proxy is the client, the server is the server, and in here, the client is the client and the proxy is the server. So now what we are saying is, we do have information about this website stored in the proxy here. We will only request, the server should only send the information if it has been modified since Thursday, September 4th. So this is what it means. Because if the information was not modified, if there was no change in that information, it means the server doesn't need to send it, because the proxy or the client's cache contain that file already. So there is no need for that information to be sent again if it has not been modified. So we now look at, so the server has responded and the status line says HTTP 1.1 304. So the status code is 304. And what does this mean? Not modified. Okay, so the server says, well, the information has not been modified since Thursday, September 4th. And it will mention its own date and time, right? So it'll say today's date is, I have sent you the response on Saturday, September the 6th at 16:22 GMT. I am commonserver.com, and that was it. So as you can see, the not modified in here means that the information had not been changed. So this is how we make use of the if modified since command. Now we will go on to look at cookies. What are cookies? When a client visits a website, the server usually will send a cookie to the client, and this will get stored inside the browser, the client's browser. What does this cookie contain? The cookie will contain information about the client. And when the cookie will sit here and it will take the information needed, and then the client at the end of the session with the server will send the cookie back to the server. So this cookie now contains information about the client, who the client is, maybe their registration details, different types of information about the client, and the server will receive the cookie back and it will store the information about the client. So the next time when the client accesses the same website server again, the server now knows, based on the cookie, that this client is not a new client. It is an existing client. The client had visited the website before. Cookies can have good use. They can also be controversial in their use. We will, in this case, look at a simple use of cookies for online shopping. So we have a client that is visiting the website besttoys.com. So we say get besttoys.com, HTTP 1.1. When the client accesses the website, we have a customer file created with a unique ID, 12343. Right? We have the unique ID. Now what the server does is the server sends the cookie, set cookie, to the client, and the cookie will now get stored at the client, and the cookie will start storing information about what the client is doing on the website, besttoys.com. Now, the client is browsing on the website, looking at different toys, different images, and the client keeps requesting different types of information. The cookie will keep updating the server about what the client's activities are. And if the client goes off and shops, looks at different items and adds them to the shopping cart, okay? Adds them to the shopping cart. All this information about what the client wants to purchase will be stored inside the cookie. Then when the client, and based on what is being requested, the cookie will inform the server to send the information. Okay? So if the client wants to access a certain toy, it will send a request for the web page to the server, but along with it, the cookie will also go, and it will keep updating what's going on. The server then sends a response back with the requesting page, and eventually the client finalizes what they want to shop. The final information about the items to be purchased, which the client has added to their shopping cart, is stored in the cookie. And then when the final page comes up about making the payment, the finalizing the order page, This cookie with the updated information about what the client wants to buy is sent to the server. And the information is updated in the cookie. Or rather, you could say the information is updated in the customer file, which is being supplied by the cookie. And then eventually, we have the order confirmation to the client saying, your order we have accepted all the items that you wish to purchase. The client will then be redirected to the payment page. So this is how the cookie works. It will sit inside the browser cache and monitor what the user is doing, the activity of the user on the website. Unfortunately, we have different websites that send cookies that can monitor the behavior of the customer on the internet and then sell this information to advertising companies. So this would be, you could say, a compromise on the security or the privacy of the client. So cookies have got both positive applications and some controversial too. So this was the HTTP protocol. In the next video, we will look at FTP.